Hello, my name is Joalix Bajandas, and I'm a rising senior from the University of Puerto Rico in Humacao from the Department of General Biology. This summer, I was admitted to participate in a Summer Research Opportunity Program, also known as SROP, where I collaborated with Dr. Sharon Glotzer at the Glotzer Lab and Jens Glazer at the NCRC Biochemical Engineering Building.
Hello, I'm Jens. I'm a postdoc in the Glotzer Lab, and we are interested in doing computer simulations of particles with shape. In particularly, we are interested in how these particles assemble into higher order structures that can exhibit novel properties or functionalities. And for example, in the past 2 months, I've collaborated with Joalix Bajandas, who is the summer graduate intern in our lab, and we were interested in examining the properties of proteins as building blocks for building biological materials.
I'm Rose Sersansky. I'm just finishing up my first year in the Glotzer Lab, and what I'm working on in respect to proteins is the shape parameterization of protein molecules, because they're not any sort of shape that we've worked with before. They're not some sort of polyhedra, so we shouldn't treat them as such. So the model that I've come up with treats the proteins as a system of overlapping spheres, kind of like overlapping grapes, which is able to capture the globularity and the different concavities and convexities of a protein particle.
We are interested in measuring the forces between two green fluorescent protein molecules that hold them together in a dimer configuration. This can be done by using molecular dynamics simulations, where we can measure the force that keeps these dimers together by doing a forward and reverse pulling simulation using GROMACS. We need a simplified atomistic model representation of proteins to understand their interactions.
Green fluorescent protein is a very versatile protein which we strive to assemble into a very controlled and ordered structure, and these kind of aggregates have to be designed on the computer first. The reason why we're interested in assembling protein crystals is that protein crystals are of extreme importance for the design of drugs and for drug delivery and for the structure elucidation of proteins. In order to learn the internal arrangement of the atoms in the protein molecule, we need an ordered arrangement of proteins in order to be able to use techniques such as X-ray scattering to obtain the spatial arrangement of the atoms. And such ordered arrangements are usually protein crystals, which are extremely difficult to achieve because in the natural environment, proteins do not like to undergo crystallization. For example, if in your eye proteins crystallize, that is usually a form of eye cataract. Or if you have Alzheimer's conditions, which I hope you don't, then this is a sign that A-beta 42 proteins condensate into amyloid fibrils. So if in nature proteins crystallize, this is usually a very undesirable condition. However, for structure elucidation, we are very much interested in producing protein crystals. And the process of protein crystallization is a highly interesting but poorly understood phenomenon that we are trying to elucidate further using our computational studies.
Overall, my experience at the Glotzer Lab and the SROP program was an amazing experience. University of Michigan would be my top choice university to pursue my PhD studies.